Okay, showtime. Let's get started. So welcome everyone. My name is Andrew Fraknoi. I'm an astronomer. I'm an educator. From time to time I'm on the radio here in California explaining astronomical ideas with bad jokes. More recently I've been writing things, particularly in my retirement, and so I do want to mention a couple of books that I did. I've been trying to be a science fiction writer like many of you. And I have the beautiful bulletin board full of rejections from all the major science fiction magazines. But in the last 2 years, 2 of my stories have gotten published in anthologies. Thank you very much. And one of them is called Science Fiction by Scientists, published by Springer, which has a bunch of scientists writing scientifically valid science fiction. And then I have a children's book that we published last year called When the Sun Goes Dark, which is not science fiction, but explains eclipses, both eclipses of the sun and eclipses of the moon. And I might say, well, that was over last year, but it's not. There's a lunar eclipse happening this January that everyone will enjoy. And in 2019 and 2020, there'll be total eclipses of the sun in South America. So if you have kids in your life or grandkids who like to learn about space, this is a children's book about eclipses. And all 3 of my books are on sale downstairs at the Silicon Valley Authors Table, which is in section B of the dealer's room, the Silicon Valley Authors. So happy to have you come by and pick those up. Okay, that's the commercial. Now let's get on to the program. So my job today is to tell you about 2 different stories. One, how did Pluto get into trouble, and what are we learning about it now? So I call it the revenge of the dwarf planet. I think Pluto is, it's fair to say, is the only planet that has brought on demonstrations. I love these signs. All we're saying is give Pluto a chance. And our story about Pluto actually begins long before the Pluto problem that happened in this century. It begins in 1781 when an amateur astronomer and musician named William Herschel discovered a planet. No one had discovered a planet before. The planets were well known from antiquity. They were visible to the naked eye. They moved relative to the stars. So everybody knew the planets before that, but William Herschel discovered a brand new planet with a telescope that no one else had seen before. We eventually named it Uranus. It doubled the size of the solar system. The amount of space between Saturn and Uranus was enough to double the size of the solar system. And this created a sensation, folks. People were absolutely amazed that there were new objects still to be found that no one knew about. So everybody wanted to get in the game of finding planets. And several people noted that if you look at the spacing of the known planets, there would seem to be a missing space between Mars and Jupiter. So people thought there should really be another planet there in between the two. And the Baron von Zach, a Hungarian nobleman, organized what he called the Celestial Police. I like to call it the Celestial Missing Planets Bureau, with a number of the most distinguished astronomers of his day to search for this missing planet between Mars and Jupiter. And they intensely scoured the area where such a planet might be, and they were beaten to the punch by an Italian astronomer named Giuseppe Piazzi. On the very first day of 1801, Piazzi discovered a planet, a small dim planet between Mars and Jupiter. Eventually, because he was Sicilian, called it after the patron goddess of Sicily, he called it Ceres. And the Celestial Police, who were really upset by the fact that some Italian who wasn't a member of the group had beaten them to the punch, said, we're not giving up until we find a German planet between Mars and Jupiter. And so indeed they kept looking, and Heinrich Olbers, a year later, did find yet another world between Mars and Jupiter, which could be a German planet. Well, encouraged by the fact that there were 2, the police kept looking, other people kept looking, and they found others. Several other worlds, not quite as bright as Ceres, but also pretty significant in brightness, and therefore we thought in size, were found between Mars and Jupiter. But eventually, the situation got out of hand. A whole bunch of planets, or actually little things, were found between Mars and Jupiter. We now call them asteroids. But actually, the first name we gave them was minor planet. And nobody protested. Nobody had signs up. We accepted that there was a whole belt of smaller worlds between Mars and Jupiter, which is either called the minor planets belt or the asteroid belt. And that series just happened to be the first and largest member of this whole new population in the asteroid belt. So that's a story I want you to keep in mind when we talk about Pluto. Now, in the meantime, let's get back to the first discovered planet, Uranus. And it turned out as we watched Uranus over the decades, its orbit was going wrong. What do I mean by that? Its orbit was going wrong? It wasn't following the law of gravity. And as you know, gravity is not just a good idea, it's the law, right? So it's very important that all bodies follow the law of gravity. And the one possibility was that way out there, gravity didn't work anymore, but nobody wanted to accept that. So why was Uranus going off course from the predictions of Newton's gravity? And several people had a great idea. What if Uranus was not the furthest out planet? What if there was yet one more planet out there, which was going around the sun out there, pulling on Uranus, and it was the pull of this undiscovered planet that was making Uranus go off course. So two mathematicians, John C. Adams and Urbain Le Verrier, each independently calculated, using Newton's laws, where this extra puller way out there needed to be to explain the amount and the direction in which Uranus's orbit was off course. And they both came up with the same result. And the first day that Johann Galle, the director of the Berlin Observatory, had their predictions, that very night he went to the observatory and discovered Neptune exactly where the mathematicians said it would be. Well, after this, mathematicians were impossible to live with. Imagine, and you pathetic astronomers, we don't need you. We can predict where the planets are. You just have to go follow our orders. And well, they got over this eventually. But it was a tough time for astronomers. And naturally, once we discovered Neptune, people wanted to play the game again. Let's watch Neptune, see if it goes off course, and see if there's yet another planet out there beyond that. And people wondered about this, but Neptune was going around very slowly, was very far out, so it took a long, long time, much longer than people had patience for us to observe Neptune, and its orbit didn't seem to be that off course. Some people thought it was, some people didn't. But anyway, people wanted to find another planet beyond Neptune. Particularly this gentleman on the left, Percival Lowell. Some of you who know the history of both astronomy and science fiction might recognize that name. Percival Lowell was a rich amateur astronomer who built his own observatory in Arizona, modestly called the Lowell Observatory, and wanted to see canals on Mars. He was the big proponent of there being canals on Mars, which eventually led to the H.G. Wells novel and a lot of other science fiction, because there must be thirsty Martians coveting our water here on Earth. And Lowell wrote books about this. It was the Neil deGrasse Tyson of his day. And it turned out he was completely wrong. There were no canals on Mars. He was fooling himself, looking into wobbly images. And he was a little bit ashamed of this, so toward the end of his life, he wanted to discover that ninth planet so he would be remembered for that and not for the canals on Mars. So he left money, even after he died, he left money in his will to search for that ninth planet and become associated with it. Took a few years to settle the estate, but eventually they built a Pluto telescope. Of course, it wasn't called Pluto then. A telescope for searching, taking photos, big photos, like you see here. Here's where we put the photographic plate. Big photos of the sky, and seeing if over a couple of days anything moved. Stars don't move from day to day or week to week in terms of their location, but objects in the solar system as they orbit the sun move from week to week. So the game was to look for moving objects. But often a picture like this would have thousands, or even in some cases millions of stars on it, and finding the one little dot that moved was a pain in the telescope. So eventually the astronomers at the Lowell Observatory didn't want to do this anymore, and they wanted a sucker. I mean, they wanted a volunteer or a lowly staff member who would do this. And by luck, a volunteer did come along. His name was Clyde. He was straight off a farm in rural Illinois. Clyde had had his own little Sears telescope, had written in to say he loved astronomy and was willing to do anything, and that willing to do anything stuck out in the letter, and the observatory director picked him to come and continue this incredibly difficult, incredibly painstaking search for a moving dot among many others. When he found the planet, they dressed him up in a three-piece suit so he would look good. And here he is later in life coming back to Lowell Observatory to reproduce what he did. They had a machine built in Germany which could flash two pictures of the same part of the sky in front of your eyes alternately. So that really helped, because if the two pictures were aligned properly in the machine, all the stars would remain in the same place, but the one moving object would blink back and forth as it flashed the two slides in front of you, the two images in front of you. It's called a blink comparator. And using this, after many, many months of searching, Clyde Tombaugh did in fact find another planet. Here is the picture on which he found it. And I want to ask you, if I hadn't put a red arrow next to the dot that's Pluto, would you have known which dot moved? No, I don't think. No, none of my students have ever said yes to that question. It's an incredibly dim little dot that turned out to move, but he did find this planet. The observatory really wanted to name it Planet Lowell in accordance with the wishes of the will, but everybody said, no, we don't name planets after dead rich people, we name them after mythological creatures. So they had actually an international contest searching for the name, and this sixth grader in England suggested Pluto, because this ninth planet was way out there where it's dark. It's dark in the mythological underworld of Roman mythology, and the god of the underworld of darkness was Pluto. And everybody said, what an apt descriptor. That's a really nice name for them to pick. That's not at all why they picked the name. They picked the name because look at the first two initials of Pluto, P.L. for Percival Lowell. So they felt that they named it after Lowell anyway by calling it Pluto. So Pluto already had a bad start. But here is what makes Pluto so annoying to the rest of the planets. The yellow orbit is Pluto. The outermost white one is Neptune. And look at this. Neptune's orbit is crossed by Pluto. For a period of time in each orbit, Pluto actually comes inside the orbit of Neptune, which is just downright rude. No other planet does this. Not only that, but you can see that the orbit of Pluto, the yellow, is tilted relative to all the other planets. If I were to take a giant sheet of paper and pass it through the equator of the sun, not something I actually recommend you doing, but if you could in your imagination pass a giant sheet of paper through the equator of the sun, all the orbits of the planets would be in that sheet of paper, but not Pluto. Pluto is tilted by a significant amount. So Pluto is also a lot smaller than the other planets. So for a variety of reasons, even when we accepted Pluto as a planet, we kind of thought of it like your weird cousin who you sort of need to invite to Thanksgiving because he's a member of the family, but you really hope he doesn't come. Pluto was already an unusual object out there, and it turned out it was much too small to have wobbled Neptune's orbit. We discovered it by searching, not mathematically. All right, so here you have a better diagram of the orbit of Pluto. It goes way out there. It takes about 250 years to go around the sun. So what's the temperature likely to be out there? Pretty darn cold. Right? So that's the first thing we know about Pluto, is it must be very, very cold. In fact, long before we went to Pluto, it turned out that we knew that it was so cold on Pluto that water would be frozen, of course, as ice, but that water ice would be as hard as rock. So keep that in mind. The temperature on Pluto is so cold that frozen water is harder than rock. You could make mountains out of it. All right, well, Eventually, other things happened with Pluto. In the 1970s, James Christie, on a photographic plate like this, discovered that Pluto had a moon. And here again, Pluto turned out to be weird. Pluto had a moon which was half its size. Now, no self-respecting planet has a moon half its size. Right? Moons are much smaller than the planets. Even the big moons of Jupiter are much smaller than Jupiter. But here is a scale model picture. By the way, each of these pictures is a real photograph. Pluto's on the left. The name of the moon is Charon, spelled C-H-A-R-O-N, after the boatman that ferries the dead souls into the realm of Pluto. Both Pluto and Charon are pictured here with the best Hubble Space Telescope picture possible of the two worlds. Pluto and the moon Charon, half its size. And look, together they're smaller than the United States. That's not okay. Right? That's not the kind of planet you bring home to mom with pride. It's a pathetic little thing. Its orbit is wrong. So you can see we were already suspicious of Pluto before we ever got more information about it. Eventually we know that 5 moons actually orbit around Pluto, but the other 4 are really small. They're more like the captured garbage than interesting moons. But in the meantime, as we were evaluating Pluto's characteristics and discovering its moons, a whole nother story comes into the picture, very similar to what I just told you about asteroids. In the 1950s, Gerard Kuiper, a Dutch-American astronomer, began to follow the orbits of comets. Comets are chunks of ice that come into the inner solar system, and when these chunks of ice get near the sun, the ice begins to evaporate, and the comets make a beautiful cloud of evaporated material. You see that on the right. This is the evaporated material. And the sun pushes back outward, and some of the evaporated material makes a tail. And these comets are beautiful. They're quite rare, but we know a number of them over the years. And Kuiper was following their orbits to see where these chunks of ice originally came from. And many of them come from much further out, but a good number seem to come from just beyond Neptune, just beyond Pluto. So Kuiper suggested that there might be a belt of icy pieces beyond Neptune, similar to the belt of rocky pieces between Mars and Jupiter. And we now call it in his honor the Kuiper Belt. Nothing in the Kuiper Belt was visible other than Pluto for a long time, but in the 2000s, we got telescopes good enough so that David Jewett and Jane Lu, first of all, I should mention, is the first Vietnamese American to get her PhD in astronomy. David Jewett refuses to have any pictures taken that aren't funny. And we know lots of people at the convention who are like that. And so between them, the two of them discovered the first little dot of a thing, which is an icy member of the Kuiper Belt. It's not especially large, only a dozen or so miles across, but it orbits beyond Neptune. Eventually, Michael Brown, who you see here with me in a time when I had a beard, this was some years ago, Michael Brown became a sort of Clyde Tombaugh of the modern era. Instead of paying a sucker like Clyde, he just had computers do the searching, but he actually set up an automated Clyde Tombaugh to search for other objects in the Kuiper Belt, and he made what is the crucial discovery. But he actually, before he did that, he did find a number of smaller Pluto-like objects. I showed you them to scale. Sedna at the upper left, Quaoar at the lower left, compared to Pluto, the Moon, and the Earth. Now you might say, what kind of a name is Quaoar? So I like Michael Brown. Michael Brown was a Berkeley graduate student, schooled in the proper Berkeley perspective on the world, and so he decided that if he ever discovered a planet or something like a planet, he would end the tradition of naming everything in the sky after dead white European mythology. That there were a lot of other cultures in the world, and it was time to name things in the sky after the gods of those cultures and not just Roman and Greek gods. And he was true to his word. Quaoar, for example, is the creator spirit of the Native American tribe that lived where Caltech now has its offices. Michael Brown, after Berkeley, got a job as a professor at Caltech. And he has stayed pretty true to this. Every world that they've discovered in the Kuiper Belt has gotten some other mythology, some other world mythology name. I'll show you more on that in a second. But it was Michael Brown and his team who discovered the crucial object called Eris. And again, you see 3 dots that move as time goes on. Eris turned out to be a twin of Pluto. So now there was a second Pluto. These smaller objects were pretty much Plutos too. But here was a second Pluto, about twice as far away. It takes more than 550 years for Eris to orbit the sun. Take your parka if you're going on a vacation. And Eris also has a tilted orbit. It's the member of the Kuiper Belt that most closely resembles Pluto. And now Pluto was no longer unique. Here is the orbit of Eris. And you can see it's also tilted. It also comes inside others as orbit. So it's every bit as rude as Pluto. Eventually, the number of objects really started to grow. So here is a slide from last year, just to show you where we are today. There you see Pluto with its moons. Eris, which is almost the same size as Pluto, has a moon named Dysnomia. There's Makemake, Haumea, which spins so fast it's not spherical. Haumea on the right, Centa, Quaoar, Salacia, Orcus, and so on. So it's turning out that there are many other Plutos out there. Some people think there might be 100 Plutos out there ripe for discovery. Now, remember, in 5th grade, kids have to memorize the names of the planets. Are you going to make them memorize all of these? You can't be thinking that mean about 5th graders, right? At some point, we have to make the same decision as we did about the asteroid count. We decided that as nice as Ceres was, it was only the first and most important member of a whole new class called minor planets. So in the same way, we were faced with all these Pluto-like objects, and we decided to create a new category. That's where we made the big mistake. What did we call this new category? Dwarf planets. And I challenge people didn't like that. Dwarf was sort of a put down for some people, and it just sounded like we were making fun of the whole category. Plus, Pluto at that time was the only planet discovered by an American, and they were demoting the American planet. This was on the George W. Bush administration, who were particularly patriotic about the country, and so there were all these problems with the demotion of Pluto. But from an astronomy point of view, you see it's the same exact story. We know 1, we call it a planet. We know 2, maybe. Once we know a whole bunch of them, we got to give them a different kind of name. And as I say, we expect that there might be 100 or more Plutos out there of a significant size. This is our modern view. We now know hundreds and hundreds of members of the Kuiper Belt, most of them small, like the asteroids, but a number of big ones orbit there. Good. All right. So that's how it happened that in 2006, the International Astronomical Union, the UN of astronomy, where each country has astronomical representatives, voted to make Pluto a dwarf planet. And even that would have been okay, except that they also voted that dwarf planets weren't planets. And that didn't go over so well. Dwarf trees are still trees. Dwarf galaxies are still considered galaxies, but dwarf planets were somehow kicked out of the planet. And that's when the protests began. I love these. Size doesn't matter. Protest for Pluto. The bumper sticker honk if Pluto is still a planet. There are many people who, when they meet an astronomer, that's the first thing they say. I don't like what you guys did with Pluto. And at the upper right, you see the Pluto station at the National Mall. I don't know if you know this, but on the National Mall between the White House and Congress, where there's always a lot of space between the White House and Congress, we put a model solar system where each planet has a station to scale. And Pluto has a place in that national model, and soon people began to leave flowers at the Pluto station on the national mall to express their sorrow at what happened to Pluto. And the next year, the dictionary folks then picked as the word of the year this new word Pluto, to be unceremoniously dropped or relegated to a lower position without an adequate reason or explanation. Now, I hope I've shown you that we did have an adequate reason, but we certainly didn't do a good job in communicating that, and not making dwarf planets planets, I think, was a big mistake. And there's still controversy about it. I don't know how it will ever eventually come out. The International Astronomical Union is meeting again this month, and there are motions to not do that anymore, to consider dwarf planets planets again. We'll see what happens. My favorite response to all this was a comedy newspaper in which someone said astronomers declare February no longer a month. They decided the International Astronomical Union has voted that February is a dwarf month and no longer a month, which I just love as a general idea. Eventually, the United States issued a set of really beautiful commemorative stamps in which they commemorated space exploration. Each planet got its own stamp, and the stamp for Pluto had a painting of Pluto that simply said, Pluto not yet explored. And a group of astronomers very interested in Pluto got really upset by this stamp and formed a committee, a group called the Pluto Underground, and they began to lobby NASA really heavily to send a spacecraft to Pluto. How can it be that an American stamp like this has to be issued? Why haven't we explored the next planet that we know? And the answer is it's far away and hard to get to and expensive, but the Pluto Underground thought, well, we really have to do it. And they lobbied NASA year after year, and eventually they wore them down. And they said, if you have a very cheap and very efficient mission, we'll let you send it. And that's when the New Horizons mission began to be put together. Here is the plan for the New Horizons mission. It was launched in 2006. It went by Jupiter for a course correction and a speed up in February 2007, reached Pluto in 2015, and this January, right around New Year's, it's going to actually go by another member of the Kuiper Belt, a much smaller and insignificant member, but another member of the Kuiper Belt. So this is called the New Horizons mission. Here's a painting of the New Horizons mission. It was not powered by solar panels, and you can probably imagine why. If you send something to Venus, there's lots of sunlight for solar energy. But if you send something to Pluto, at Pluto the sun looks much dimmer and you don't have enough energy to power the craft. So we have to power this with radioactive materials inside, and this is really a wonderful coincidence. The radioactive material that it's powered by is plutonium, which, if you didn't know, was named after Pluto. Just like uranium, which was discovered after Uranus was found, was named after Uranus, and we have neptunium, named after Neptune. Plutonium is named after Pluto. So plutonium powers the Pluto spacecraft. Plus, the ashes of Clyde Tombaugh are on board. So they managed to send the Discoverer to Pluto, which is really sweet, if it's not too morbid for you. So we put the New Horizons spacecraft right there where the plus sign is, which is quite an achievement, right between Pluto and the orbit of Charon. And the NASA people were bragging that this is like making a hole-in-one from Los Angeles to Washington, D.C. So it was really quite a good job of steering, and they couldn't wait to hold up this sign. Pluto explored. We did it. The man on the left is Alan Stern, who was really the great guiding force and still is the chief scientist behind the New Horizons mission. He was just so thrilled to be able to hold that up. So here is what Pluto looks like. Let's get to the good stuff. Let me now take you on something that was not possible until very recently, a guided tour of Pluto. And the pictures really are amazing. So here, this is slightly exaggerated color, but a global picture. What color is Pluto? Reddish. We got to explain why that is. Where did the red color come from? And then if you look carefully, you can see Pluto has a heart.
Can you see that?
So we may not have treated it well, but it has a heart for us. So here's a close-up of the heart, and now the colors are a little bit less exaggerated, and you can begin to see quite a contrast between the various features of Pluto. Let me point out some things to you. Can you see that here in the dark reddish area, there are a lot of craters? Craters are formed when chunks of material hit a world and explode and make a round hole called a crater. So the number of craters shows you how many times a world has been hit. What would hit Pluto to make craters? Well, other smaller members of the Kuiper Belt. The icy chunks that orbit with Pluto occasionally collide with Pluto or with each other and get knocked out and into Pluto. And so we have over the many, many years, billions of years, on the red dark area there, lots and lots of craters that have formed. On the other hand, look at the left side of the heart. Here's the heart. Here's the left side of the heart, which we call the Sputnik region in honor of our first spacecraft. And Sputnik is completely smooth. We can't see any craters. Very different from the cratered areas that are reddish. Sputnik is also much lighter colored than the rest of Pluto. So, and it turns out to be completely round, very much the same shape as craters are. So one idea we immediately had, which is still pretty good, is that the Sputnik lobe of the heart is actually a giant crater that formed early on in the history of Pluto, and something is filling that crater, and that something that fills the crater can't accept any hits anymore. Well, that can't be right. Things hit randomly. So whatever hits there must be disposed of by that area. That's true on Earth too. If a giant rock hits the Earth over Siberia, as happened in the first decade of the 20th century, you might get a big mark. In that case, it exploded high up, so we didn't get a crater, we just got a devastated area. So if things hit over solid land, you get craters. But if a chunk of rock hits the Earth in the ocean regions of the Earth, it just splashes down into the ocean, and eventually the surface returns to smoothness. So could this be a Pluto ocean? Could this giant bowl be filled with something which is not frozen solid at Pluto temperatures? Is water frozen solid at Pluto temperatures? Absolutely. So all the mountains, I'll show you in a minute, are made out of hard rock ice. That is ice frozen as hard as rock. But whatever's in that bowl has got to be more liquidy, and that turns out to be liquid nitrogen. Liquid nitrogen is what your dermatologist uses to freeze little knobs of flesh on your skin that you don't want to have there. It's it has the ability to be a gas at pretty cold temperatures, and it takes a very cold temperature to make it liquid, and then even colder to make it solid. So we think that there is actually a liquid to solid nitrogen glacier inside the bowl. It acts in some ways like a solid, in some ways like a liquid, much like glaciers on Earth do. They flow like a liquid, but you can often stand on them. So we think this is a nitrogen glacier with some other things mixed in, other materials mixed in. So that was a big discovery. There was an ocean of a kind on Pluto. And then we also found out what the red material was. The red material was methane from the atmosphere, hit by sunlight even that far away, and converted to more complex chemicals, what we call hydrocarbons, which rain down as red snow on the surface of Pluto. So this means that Pluto must have an atmosphere. We actually knew that from Earth measurements, but we really began to learn more about that as we got closer. Let me take you through now on a tour. Here you see the Sputnik region much larger. You see the dark region putting its head up. There's a big move to call this dark region, now tell me if I'm pronouncing this right, Cthulhu? Cthulhu, yeah, which is an H.P. Lovecraft named for the terrible monster in the dark. I don't know if they'll get that. This is Sputnik, and you can see the cratering much more clearly here. But here's the picture I wanted to show you. This is a remarkable picture. It's about 50 miles across. And what you're seeing here is the absolutely rigidly described, clearly described beach of the region made of water ice. And then this is Sputnik. And what do you see in Sputnik? You begin to see that it's divided into cells. What kind of cells are these? Well, how many of you lived through the 1960s? Okay, so you guys explain it to the rest of the crowd. Back in the 1960s, there was something called lava lamps, and we would stare at them for a long time when we had done interesting things. And these lava lamps, if you watch them, had these cells, so hot material moving up and down and making just this kind of cell structure. If you're not a child of the 60s, let me mention miso soup. If you boil miso soup, you get the same kind of cellular structure. In the sun, we get the same kind of cellular structure. These are called convection cells. They represent the process of convection, which is hot material moving up and colder material moving down at the boundaries. So there are convection cells in the ocean, the nitrogen ocean of Pluto. And then here is a picture about 75 miles across, but in color, showing you the convection cells. Can you see the cells on here? You can see that there's some dune-like features on the nitrogen glacier. And these, ladies and gentlemen, are water icebergs, really solid water icebergs around which the liquid nitrogen flows. So about as eerie a picture from outer space as we've ever seen. Really amazing. And all these pictures were paid for by your tax dollars, so they're available free of charge on the web. The water is hard, right? So it's an actual obstruction that goes down. It's not necessarily floating. It's going around. Could be an island, that's right. If you have never seen convection, here is, I just took this off the web, what everyone has in their kitchen, a mixture of silicone oil and aluminum powder heated in a frying pan, but it happens to give you a very good sense of convection. And again, this is a picture that's not actually a picture. It's been tilted to give you more of a sense of perspective. But here you can see that here's the shores of the ocean, the convection cells. And here you begin to see the mountains made of water ice. In this case, sticking up about 1 to 2 miles. But some of the mountains we observe are actually 3 to 4 miles high. All right. Well, I want to finish up with just a couple more pictures. Here is Pluto as seen from behind. Now, what do I mean? This is Pluto making an eclipse of the sun. So the sun is behind it. Sunlight is filtering through Pluto's atmosphere. You're behind Pluto on the other side from the sun, and you're seeing what it looks like when sunlight filters through the atmosphere of Pluto. And what color is it? Blue skies on Pluto. Isn't that amazing? Blue skies on Pluto. And so someday, when there begins to be a conspiracy theory group that says NASA never went to Pluto, just like they're claiming now we never went to the moon, and you want to prove to them that we actually did go to Pluto, remember this picture. This picture could only be taken from the other side of Pluto. So there had to be an observer, a spacecraft, on the other side of Pluto. NASA did go to Pluto. This is the proof. And then an amazing picture showing you the layers in the atmosphere. It's a very thin atmosphere, but it's apparently warm enough. There's nitrogen, there's methane. It's warm enough for haze, for layers of smog. Reminds us of a Los Angeles picture. Layers and layers of smog in the very thin atmosphere of Pluto. And then down below you can see the mountains really clearly because of the sunset shadows. Can you see the heights of the mountains down below? And the Sputnik region goes off to the top right. Remarkable picture. The atmosphere of Pluto clearly revealed. Here is the darker region to show you the craters more clearly. But I want to finish up with Charon, or Karen. Here again is the two worlds to scale to remind you how pathetic they are and dwarfy they are. And here is Karen. Also interesting. Somehow the red material from Pluto has fallen on one of the poles of Karen. This is actually the coldest spot on Karen, and has remained there as red snow. So this is stolen material from Pluto. Karen doesn't have an atmosphere. There's also a giant trench here, which may be kind of cracking when the moon froze. And then the most remarkable thing, one close-up of Karen, there's a mountain in a moat. What? There's a crack, a crevice, and rising out of it is some kind of icy mountain. What the heck is a mountain doing in a moat? That's for future PhDs to figure out. But I hope you will agree with me that this is amazing exploration. We have one more destination, the chunk of the Kuiper Belt, which we've now nicknamed Ultima Thule, after the unknown parts of ancient maps. And on January 1, we will actually get close-up pictures of this much smaller member of the Kuiper Belt. So as I say, I hope you'll agree with me that all this has revealed Pluto to be a fascinating world, and you'll agree with the bumper sticker, Pluto, you will always be my favorite planet. Thank you very much.